Okay, there you go. Okay, so for everyone who starts, who joins in later and goes through the recording of our session. So number one, welcome. And number two, I just want to give you a brief introduction about what this training session is going to be about. Number one, we are focusing now. Azam has been focusing, as you know, our main R&D research and development is on developing this AI-driven diagnostic tool for the early detection of Alzheimer's disease. And for this purpose, we have been now focusing more on tau pathology and amyloid PET and what these basically entail and how we can use them to further train our model and get the desired results. So, just to give you a little bit of a brief reintroduction and background on what we're doing. So, essentially, what happens is in the current state of the art, if a person is having symptoms related to Alzheimer's disease, they would go to a doctor, a physician, and to a specialist, and they would get themselves checked out. The doctor would go through a question and answer session with them, and based on the answers that are provided, if there are symptoms, they would first schedule a MRI or fMRI, and they would use those results to try and single out if it's any other problem like internal bleeding or aneurysms or anything that might mimic the symptoms of Alzheimer's disease. If those are not the case, then they think it's Alzheimer's, but they want to double check it and they want to confirm it. Then they send, if the person is eligible, the patient, then they send them off for these amyloid PET exams. So what that exam entails is it's an expensive exam as opposed to a simple MRI, which costs about 7 to 800 reals, Saudi reals. This PET amyloid exam costs about 12,500 reals, and it's invasive. It involves the injection of a radioactive tracer into the patient, and then that travels up to the brain. And then after that, the imaging is done to tell if there's presence of protein that is not being broken down. It could be tau, it could be amyloid. So it's a longer process. Now, what our system essentially aims to do is it aims to eliminate the need for that exam. And what Azam is currently focusing on is he's focusing on training our data. So our data is already trained on MRIs and fMRIs, but we're also trying to train the data on tau and amyloid. So what that would do is essentially that would teach the system, teach the model on about how the brain composition changes and how different things change with respect to tau and amyloid. So when the presence of tau and amyloid is there, what effect would it have on other parts of the brain, like the hippocampus or the other parts? So now he's trying to train the model and develop a system in which it gets to the point that through a simple MRI or fMRI, we are able to predict whether there's presence of tau tangles or amyloid protein, and hence Alzheimer's disease. So I will just quickly hand it over to Azam. I know there's a few students who joined in today. Guys, a lot of people message me because they're having exams. So I thank you for joining in. I know, Ahmed, you have exams as well, and some other people too. But thank you for joining in. And for those of you who can't be with us right now, they can always go through the recorded session. So, Azam, I will hand it over to you, and you can just quickly start off with the presentation, please.
Okay. Now, this is also the sequel of our previous um, uh, lectures regarding data preprocessing technique pipelines for AI models. In previous lecture, we also taught about different techniques for data preprocessing, especially by using fMRI prep, because many students in University of KSU and other King Faisal Hospital also dealing on fMRI, because fMRI is providing more comprehensive result regarding the MRI for specifically disease like Alzheimer. Now, today our agenda is how we convert the DICOM to NIFTI. In previous lecture, the library is also available, DICOM to NIFTI library. which is also utilized by many organizations and many tools. Today, I selected a tool, MRIcroGL. It's basically a voxel-based neuroimaging tool, and it has also a feature to convert the data DICOM to NIFTI, DICOM to 3D slices, 2D slices, and other things. Uh, and second agenda item is, uh, as Sir Ahmad also discussed, that we are also trained the model on PET amyloid tau tangle. Basically, these are the bio tracers which inject in the patients different tracers in both of cases like PET amyloid and tau tangles for diagnostic of Alzheimer disease. Basically, we train the model by the utilization of the techniques for our MRI, because the cost of the both tests for PET amyloid and tau tangle is a, futuristic biotracer for the analysis of diagnostic Alzheimer disease, and we utilize the data sets of ADNI4, because ADNI4 is only a data set which is also launched in 2025 and 2024, specifically for the PET amyloid and tau tangles and the
Azam,
other.
I'm just going to add something over here. Sorry to cut you. So, regarding our research collaboration with King Faisal Hospital, I'm saying this because Ahmed is also on the call and he's sometimes he gets in touch with them. So, Ahmed, I know we sent in the request to Shella regarding, and she forwarded that on. So, for request for data for MRIs and fMRIs. So, Azam sent me the requirements document and I forwarded that to her. But I have recently made a change request to her last week, or sorry, earlier this week, and I sent her a request to add data for PET amyloid and PET tau to it as well. And I also sent her the explanation why we're asking for that addition to the data, because now we are also training the model to it. So hopefully she is able to incorporate it in the request for data that is then submitted to King Faisal Hospital. So she hasn't updated me as yet, but hopefully we hear back from her in a week or something, next week maybe. But just to let you guys know, I updated that requirements document because we'll be needing this data from them as well. But meanwhile, as Azam said, he's using the data from ADNI and other sources as well. Please continue, Azam. Thank you.
Okay. Now we are utilizing two sources data. First is adding and second is gain. Gain is other platform which is also collaborated by 31 more than 31 organizations for data sharing. Specifically, the PET amyloid, tau, and other fMRIs also available in that. Now I show you the Alzheimer. Basically, such data is utilizing for our model. Uh, in case of amyloid, in both the model, amyloid has many bio tracers for the diagnostic of Alzheimer disease. The first tracer is fluorobetabine, and the third is NEV 4694. Basically, these are the biomedical name of such biotracers which are injected in the patient. As you see that the amyloid has approximately to 6 to 7 tracers, but these are the more common tracers which results are too much better. That's why the ADNI utilizing the such patients on the data for such tracers. As similarly, the tau tracer also take 3 tracers. You see that in the columns, first column is target injected, which means that the target, how many dose injected the patient, specifically 10 cc is the dose, is the maximum dose, and minimum dose is 5 mcc. And in the last column is that after injecting the dose, how much time takes from imaging of the data. It means that after injecting dose 50 to 70 minutes, after we take the MRI, the imaging of the data, and trace that which part of the brain is um, have Alzheimer symptom. Similarly, all the sets detail, and Similarly, the gain has also such type of data. I share the link you and also I upload some subjects data on over GitHub repository for your experiment purpose. And the last agenda item is the N8 and workflow for building AI agent. Because I feel that many of the people are not a programming aptitude, and you guys are also dealing in medical field, and some students which are not medical field have also have somewhat experience regarding the AI. But the people who have not do not have experience on AI, but he want to build AI models like chatbot, AI assistants, and medical assistants, and other um chatbots which are helpful for regarding the medical perspectives and your other daily tasks. Now, I also discuss. I recommend you people to work on N10 workflow. It's easy workflow. Just drag and drop the things, and after that, the workflow is ready for you. Now I move forward for our first agenda item, how to convert DICOM to NIFTI format by using MRIcroGL. Basically, this is a screen of intro screen of MRIUL when we load some image, and there are different type of templates are available on that. When we select the template for SPM 152, the SPM 152 embedded from MNI template, uh, and you see that all the three axes of the brain are fully ready for the diagnosis purpose because all the skull stripping and bias collection, all the things are done in such template. And the basic purpose of pre-processing is that after the pre-processing, our data is embedded in a template like MNI because the MNI 152 is a standard template for brain. And now visualize the next screen. In such screen, you see that there is also a import button in the tool. Now, after the slides, practically demonstrate that how the things are working on uh, because these things are for your recall purpose, how the things are working and how the things are doing in the software. We click on convert to DICOM to NIFTI format. After you see that, we have a next window, and in such window, we just select the folder, you drag the folder of which you convert your DICOM to NIFTI format, and some options are available that the output directory where your output NIFTI file is resided and how which output format you needed. And NII.gz is a compressed format and it is recommended that you compress the format because it's limitize your and save your memory and your space. In case you also select the NII format which is without compressed format, and the option is that yes, anonymize, it means that when you convert your DICOM to NIFTI format, all DICOM format has a identity of a patient and is labeled that. But in case of your analysis, you label according to your requirement. That's why you select such option, and the identity of the every slice is removed by such option. And similarly, you have the other options like the size, Philips scaling, because many machines are using for Philips and Siemens, and scale means it's also your alignment and other things. And during the process of conversion, all the things are managed at the end. Similarly, you have the option of crop 3D images and other options. Now I move forward. Now this is a format when we select some functional MRIs, fMRIs. This is basically functional fMRI view, and you see that there is images of and the at the bottom the time slicing also show you. And if you see
Azam, sorry, I have a question. Can you also post this software or the link to the software in the after the
yeah,
call,
yeah,
after
yeah,
the session?
yeah, yeah, no,
Please post it. Please
I
post it
also
in the group as well. And then the students, for those of you students who then view this training session, I would suggest that you go and explore this. And then obviously, as soon as our machines get set up at the lab at KSU, then you can also use those machines to use the software and other software that we will make available to you. We're just waiting for the internet thing to get resolved from the university side so that we can start with that. And please continue, Azam. Thank you.
uh, you see that in my screen. This is basically a screen where basically there is some speed issue of downloading in Pakistan. So there is some problem in the downloading stream. That's why the downloading is not. I see that the software is already downloaded in my site. Wait a minute, just a minute. Uh, yeah, the software is also available in my site. Now I am open such software. Basically, this is the software name as MRIcroGL. This is a basic screen of the software. Uh, when I selected the screen, there is basically templates or different templates which are available from the standardization of your MRI, yeah, fMRI. As you see that I am selecting such templates, or very dark template, and when you selected that, you see that such like a flare like MRI there, and when we open the Christie one, such is another structure which is available there, and um, when we open that in a format of MNI format, basically the MNI format is a standard format which are recommended uh, for researchers, and if the results is too many good for the analysis. As you see that when we select a SPM 152, the SPM 52 and MNI 52, just like a similar type of resemblance. And when we open that, the other template like the SPM motor, you see that it's like other thing. And when we select a visible human, it's just like the human structure, the blood flow structure of a template. You see that the blood shadows are prominent in the brain part. Now I move forward that how we convert that from our NIFTI to DICOM format. As you see that we have a import button, and when we select the import button, we have the option of convert DICOM to NIFTI, convert TIFF to NIFTI, convert folder to the TIFF to NIFTI. If you have a 2D images, you also convert in the NIFTI format. There's different type of options available, and you also have other tools like rotation, resizing, cropping are also available in that, because it's too much easy tool, and you people I think so it's easy for you for converting your data, because I feel that many people have the problem for converting of data. But I recommend you, after this is basically a starting task of you people, because many people are no familiar for the bash script and the commands. But I recommend you must understand the pipelines, because when we prepare analysis and we have a data in a stream format, and the data set is too much high, just like for training of model, yeah, analysis, some high level analysis. Now we recommend that you utilize the pipeline when you have some um, you have emergency time, and you have not familiar to such command. Such tools are also helpful to you. You convert your data easily from such format, and after that you put the data from bit structure and put some pipeline, for analysis purpose. Now I click on that. After the click, the screen is available on my side, and we have an option. Either we drop back the folder here. Yeah, after we have the option for select to convert data. I select the option select to convert data, and I give the path of the data. Uh, I have a training folder, and in training folder, I the dataset folder, and such as the DICOM. I selected some DICOMs MRI, and basically we have four folders which have a different type of. Uh, um, First of all, ICU. Uh, we have you see that we have folder, and folder we have already. I We have a different in one folder. We have approximately. You see that we have approximate the properties that you see that we have 144 DICOM files. One di and all the files have just like a pose of an image. And in NIFTI, all the files are embedded in one NIFTI file, which is basically all the slices are collectively injected in one NIFTI file, and that's the purpose to convert the NIFTI, because the analysis, the NIFTI format is a recommended format. Now you see that in other folder we have also such like quantity, I think so 144, 144, all the folder have 144 DICOM files, because these shots are taken from one patient from one machine, and all the uh, basically this is the identity of the patient, which when we take a shot of a person for MRI, we encoded for reference to ID. Basically, such IDs are also embedded where the all the DICOMs files are taken. Now we we also create a folder in here uh, and name as NIFTI conversion. Now after you see that we select a folder, and we select the main folder. The main folder is that over the such folder, and after the selection, the data is loaded. That after the loading, we also wait. I the all the Because I am not selected the folders. Now all the nifties are converted in the similar folders. Now I select that. Um, in dataset folder, and you see that all the nifty files are available in the first nifty file, and the second nifty file, third and fourth, because I am giving the four folder, and one file is also the file is JSON, because it also convert the JSON file. JSON file basically the file which give you the all the information of the such DICOM. You see that the DICOM is MRI strength, and the image frequency, the manufactured machines, the institute which the procedure is proceeded, and also the protocol used for Alzheimer, and similarly the MR admin confirm such series of the description. Such all things are available on the NIFT admin side, and all the terminologies are available. You can read that, and you see that the software, which is basically it is only the recommended software. Other softwares are also available for DICOM to NIFTI, but the results and the standardizations of different organizations prefer that you use DICOM to NIFTI library. Such library is also embedded in over a pipeline, which are already installed in the machine. When the internet connectivity is available, all the things are ready for your use. Now after the conversion, I open such file, you see that we have file open, and after open that we open our first. You see that it's a better result. How the files are converted and how the files are converted in a better resolutions. And you see that we have the cursor, and we have such like the arrow when we move right, and you see that the other slides are already changed, that the slide view. Similarly, when we select the left view, the and similarly when we select the A mean aerial view, and the aerial view also, you see that over aerial view is also converted, the slice number is also changed, that you see that uh, in the top bottom, the size is 96 multiply 119 multiply 1. The first is x-axis, the second is y-axis, and the third is over z-axis. And similarly, the secondary view, we see that is a secondary view. No, it is, and overview is also changing that. You also change for your view for such similar drag and drop that, and you have already also a option. You select that the coloring options. Basically, we have different type of coloring region. If we use info, this is basically a good region. You see that the different areas are prominent. The tissues areas from a such, and you see that over the gradient line. You also change your color gradient line for such that, and you also change your opacity and other things. You see that. See the opacity means their lighting, and you also um, zooming that, the zoom that, and you also ruling that. Yeah, this is a ruler. When you select the ruler is also available here. Basically, such idea is that for people who are not familiar for the commands or use such um, thing, such software, and you see that I select another MRI, and you see that the other MRI, the structure is that like, and I also select that the last one. This is the last one. Last one is not much prominent as to see the first one. And you see that after we have a different type of variants. If we select the copper, you see that this is the copper view, and the other options are also available. You can also explore such options, such a lot of options available. That now, if somebody have a question regarding such point, shared.
Thank you, Azam. I think this is going to be very, very useful, especially for Dr. Schwag students who later on log in and view this training session. I would suggest that you absolutely get access to this tool and then you start practicing. And then you can go on this training session and then you can rewind it as many times as you like. And Azam has walked you through step by step through everything and just follow his lead. And if you have any questions, please send to him. He's welcome. Always available to schedule a call during the middle of the week if you need him for one-to-one training. No problem at all. Azam, please continue.
Okay, now I move forward to slides. Basically, this is a demonstration and the view of the slide. I also demonstrate you in the software. It's a grayscale. You change the scales from that. After the slide view, basically, you also impose over real-time MRI, fMRI for template.
Sorry, one second. I see someone has their hand up. If you wish to speak, please, you can go ahead and ask the question.
Okay.
Or you can message it to me. Someone had their hand up in the call.
If somebody question, please speak that. I think
Uh,
so.
Hello, Azam and Ahmed. Thank you so much for your effort. I would like to ask now, for instance, some of the pictures are not clear in specific colors. So you think that if I change the filter of the pictures, it would be more clearer, right? Much
Yeah,
clearer.
yeah, yeah. There is lot of options and lot of templates are also available in such software, and you can change such thing because it is demonstration and the intro of the software. If you see that, I move for
Yeah, I wanted to ask, based on what I choose the filters? Based on
yeah,
the
yeah, there is a lot of filter you choose that basically all the filters are available that you choose according to your requirement. I basically the normal the basic filter is the grayscale. Grayscale is also using that, and the second is that how the results of your MRI and fMRI, because you see that if I open the first MRI,
Mhm,
it's more clear because it's take you see that
mhm.
the imaging of such MRI is too much clear. It depends upon your data how or the data is without the pre-processing. It's say raw data available from the ADNI side. After you that you applying some techniques on that, you applying such pipelines technique like normalization, skull stripping, because the skull is also aware is embedded in such MRI. When we if you see that I select the standard as a demo MRI available in such software, I prefer your data is after processing in such shape, because such shape is too much prominent from the analysis point of view. And such stage is also when you applying all the rules, normalization, skull skipping, and just data augmentation, and also applying such template. In previous lecture, I am discussing about the MNI template because MNI is also a template for Montreal University for Canada, and such templates are also available in fMRI prep, and such things are also available in the software. You if you explore the software, there are a lot of things you apply that, some template scripts, color schemes, and other things that
Thank you
okay.
so
Okay,
much.
perfect. Thank you, Azam. Please move ahead.
Okay, now the software has also a facility you can map a layers.
Uh,
You map a layers on your data. You see that we embed a layer of.
Azam, sorry, I can't see your screen. Did you stop sharing?
Wait a
No, the
minute.
screen is clear. We can see.
Okay, wait
Oh,
a
you can
minute.
see it?
Yeah, yeah, it's clear.
Okay,
Wait.
she can see it. Why can't I see it?
Uh,
Yeah. Can you return to the
Okay,
system you were using? It's
okay.
not
I
working here.
I I can see it now. Thank you. Thank you.
okay, everyone see the screen?
Yes.
Yeah, okay. Now, the also the feature in such software is you can embed the template. These templates are already embedded in the software like MNI 152, SPM 152, and you also layer of your MRI for such template. In future lecture, I also give sub lecture how you can map such thing on that. But in such a lecture, the basic purpose is that the conversion of the data, because in one lecture, the all the things are not demonstrate for you people. That's why I take images and I take some, because some coding and some other settings are applying on that. That's after that the picture is demonstrated in such like that. And after that, we have also a result compilation features. You see that the some areas highlighting that, and you also put some templating on that, and the areas on your MRI and fMRI highlighted that. And the last, now basically such some features of the software, some other softwares are also available And in the next lecture, I also introduce another software. Its name is ITKSP. Such software is also a too much of software. The discrimination from such software to other software, because every software has some ability and some extra features. In such software, the extra feature is that the conversion availability is also available in that. In some software, the visualization is too much clear, and the visualization, 3D visualization is too much clear. And the software like 3D Slicer, ITK, have some visualization feature are too much good, but they do not provide the conversion feature. The idea of the people in such lectures is that in previous lectures, I taught too many things and too many code strips. People have a problem for conversion of data and such like thing. That's why I am demonstrating such software. I hopeful such software is useful for you people. Now the second part of agenda item is that how we analyze the three, because there are two types of diagnostic feature for Alzheimer, early detection of Alzheimer. The first thing is without a radiological and biological injection, yet biotracer is that we take a MRI, fMRI of a patient in T1 and T2 weighted images, and after applying some algorithms and some models like explanation AI, gradient cam methods, and other segmentation and other thing, we detect that the parts where the Alzheimer symptoms are available. But in biomarker, bioinjections is more because some things are embedded, but the cost of such tracer is too much high. I think so, approximately 10,000 to 15,000 from each test for amyloid and tau PET, and some radiation effects and some other effects are also available because some biotracer is embedded in your blood, and the blood flow through your brain, and such process is basically called centroid. Centroid is the PET amyloid medical uh,
Azam, I'm
I
going to
am,
add something over here, if you just give me maybe 2 minutes. Okay,
yeah.
so guys, for you guys who later on view the recording, and for everyone over here as well, although I know you guys are very clear on this, but for the other students who are not here today. So amyloid and tau, you have to get this concept into your mind. What happens is these are proteins, like for example, amyloid is a protein, and your brain builds proteins and then it breaks it down. That's the natural process. So the protein builds up and the brain then breaks it down. It's for a natural brain. Now, what happens for Alzheimer's patients is protein like amyloid starts building up, but the brain does not break it down. So that's a problem. So when the protein starts building up, what it does is it starts actually eating the brain. Okay, so when you see the MRI or fMRI image of such a Alzheimer's patient, you see that on the border of the brain, you see these widening gaps appearing. Okay, so one that widening gap is actually the amyloid and the protein that is eating away at that part of the brain. Number one. So number two, what you have to keep in mind is how this process works is yes, it's an expensive exam ranging between 10,000 to 15,000 Saudi riyals. What it does entails is you go to the doctor will inject into your bloodstream a biotracer. That tracer travels all the way through your blood into your brain. Now, if there is amyloid protein present in your brain and there's a buildup of it, that biotracer will go and attach itself to it. Okay. And when you go for the PET scan, that will then show up as a colored area. And that is then the diagnosis of Alzheimer's disease. So currently, that is how they do it. And what we are aiming on doing, and Azam is trying to train the model on it. What we are doing is we are trying to get pairs of data. So we will get data from a patient who's had an MRI or fMRI done and who's also had a PET amyloid exam done. Okay. Then we will compare the two results. We will see the effects of the amyloid on other parts of the brain that can be diagnosed or that can be analyzed just from the fMRI alone. And then we will build up a model and we will teach the model that, okay, you know what? A brain that has amyloid or abundance of amyloid has these features, which are then showcased in the fMRI. So once we train the model on enough patients and on enough data, there will come a time that the model will be able to, just from assessing and analyzing a fMRI, be able to tell you if the patient has amyloid or not. And that would be a real breakthrough. So that is what we are currently working on. And Azam, thank you. Back to you.
Okay, basically, Sana Ahmed likely say that the idea is accurately such that because it takes time and also take save money because in simple MRI you take just like below $1,000 for every MRI. I think so. It takes 600 to 700 real dirham in Saudi Arabia if you take a MRI and fMRI test. But in case of amyloid, it takes more than 10,000. Now I move forward that the idea is that after you see that there is some libraries of segmentation because the segmentation, this is a segmentation. All segmentation is a area. Wait a minute. Now I think is clear that segmentation is a area which voxelize all the voxels of the brain. Basically, there are three view of the brain. You see that tissue segmentation. Tissue is an area which are uh, suffers during the Alzheimer, and the proteins are also break down such tissues areas. You see that the areas which are in the red areas are the area which are the protein break down such areas of the brain. Similarly, such areas there are different views of the brain. Basically, the outer layers are normally much affected from such Alzheimer, and the such like area, the such inner area is also affected. That area are basically infected in Alzheimer disease, and the process that when we take the segmentation, the software like P-Server is the only software which are better analysis for the segmentations and the parcellization. Both are the same things. And in fMRI prep is only a software, only a software no is only a pipeline which also embedded all the things like data pre-processing and after the pre-processing the segmentations of the brain plus bold analysis, because the bold analysis is analysis of your blood on your brain area, and which is mapped by the MRI, fMRI, because in MRI, the bold area, the bold analysis is not feasible because the MRI is 3D view, but the fMRI is a 4D view. And you see that after the applying some libraries, because such libraries are available, and we conclude and we apply some things on the area, we conclude that the white matter volume is 373, and these volumes are available in centimeter and in inches, and the sizes are also available in that. Similarly, these are basically the labeling features when we applying the segmentation on tissue. After that, all the labels, yeah, all the voxel ranges are available with that, and we record such things in our data files, and after that we generate a report for such figures. You see that the other analysis is microstructure segmentation. The first analysis is that tissue segmentation, and the second is microstructure. Microstructure basically focus on cerebellum, and you see that is also tell you that total cerebellum feature, right side cerebellum, left side asymmetry. Such things are also available in your brain anatomy. If you are because before learning all the things, you cannot build the model. Such things are also available, and I explored that more than 130 labeling is also available for brain or not or nautical labeling. I explored that. I think that its range is also increased, but I explored 130 labels in such report. I map 130 level in next slide. You see that structure segmentation. In structure segmentation, you see that we have also some hippocampus, because the hippocampus also tells you about the Alzheimer, because in the Alzheimer patient the hippocampus value is shrinkness, and the thickness of the hippocampus is shrink that, and the how you can count that from the value, standard value, how the value you detected for the segmentation. You see that in case of such MRI of a patient, the value is that, and after that you have another
Azim, I'm
frontal
going to
lobe.
add something about the hippocampus over here for everyone's clarity. So the
Yeah,
hippocampus is a part of the brain, and it is one of the first few parts that are affected when Alzheimer's disease takes over the brain. So what happens is the hippocampus starts shrinking, and the thickness of the hippocampus goes down. That process is called atrophy. So where the doctor sees atrophy, which is shrinkage in the hippocampus, then that is one of the signs of Alzheimer's disease having taken over the brain and affecting the patient. Now, what we're trying to do is we're trying to see, okay, you know what, the same patient has had a MRI, fMRI done, and these are the numbers for hippocampus and everything else. And then the same patient has had a PET amyloid exam done, for example, or the tau done, and that amyloid exam has diagnosed the patient with Alzheimer's. So then we come back to the fMRI and we come back to this table and we compare this table for the same patient between the fMRI and the PET amyloid, and we see, okay, what's going on with the hippocampus? What ranges does the hippocampus have to be in for the patient to have amyloid? And then that is how we reverse engineer it and we train the model. So that in the future, from a simple fMRI, the model is able to extract what the hippocampus value is. And based on the hippocampus value, it can then determine if the patient has amyloid or not. So that's essentially what we're trying to do. Azam, back to you. Please continue. Thank you.
okay. Now I move forward to last agenda of today. Our lecture is that the NA10, because the NA10 is a top of the art workflow for building AI agents nowadays. And I just for all people, just overview that in next lecture, because due to the time shortage, in such lecture I cannot demonstrate practically for you people how to build an AI agent, but I brief you what is NA10 and how it's working. That basically NA10 is a workflow just like that. Uh, when you build something, you make a workflow in the form of flow chart, yeah, in the form of some diagrammatically chains. Basically, the workflow is just like a flow chart. We move forward that. Example is that basically such a workflow that the workflow is that first of all, a user sends some prompt information. You see that basically the first is the writing, the person giving some prompt from AI assistant for doing something, and he is writing in the in case of writing, in case of voice, in case of giving image, the three possibilities that from giving the prompt. Normally, the text format is commonly used by people, and in some cases, in our case, we are also building a AI agent from NarrowCogni platform. In the future, I also demonstrate you how it's worked at. In our case, I am giving the MRI images for our agent, and our able interact to the model and give me the some classification and interpretation of such disease and such symptoms. In NA10, first thing is that you give a mm, uh, prompt. In case of text, voice, it depends on you. And after that, you select a agent. Agents mean any AI, your own agent, and you utilize some the market available AI LLMs like OpenAI, like Gemini, like Claude. These all are the available and working for you as a agent tool. You apply that, and after you see that there are some chains. Such chains are giving your model give you also interact. So from your own model, your own AI model, you see that you also give you memory location. You also interact your model to some database, and after that you also you see that three type of chains your AI agent interact that some models, some memory space, some tools like you select if you build a model for weather information, you interact a tool for some weather libraries available freely in the market, and you interact that. After give the information get, you send your prompt from some weather information such like that. I am writing a prompt. Please give me the temperature of Lahore today, and the model or AI agent pass to the information to the tool from some libraries which are also available the information, and the information passed on to agent model, and agent give the result from our model. Such a idea and such is very powerful idea for making AI assistants and other things. And if I move forward that, you see that we have a different uh, type of examples are also available free of cost. Basically, the N8 model is not a free model. It gives you the 14-day trial period, and after that you have a subscription of $20 per month. But there is some you change email address and some other things. You give a trial, extend your trials in a training session, and if you see that. Uh, First of all, you people, because my trial is recently expired, this is the thing you go to the site, and after that you have the option of start a trial. You give your option of your email and other things, and after that you have the 14 days trial available.
Uh,
Uh,
Thank you, Azam. I'm just going to add something. So I've tested the site. I think it's really, really good. So I would suggest for anyone who is interested in building AI models, this makes it much easier. You don't have to do programming, and it gives you a very easy to use interface, and you can try building different models with this. So please go and register and try and experiment with this. And then if you need any help, then Azam is more than welcome to walk you through it. Again, we're trying to find solutions for people who don't know programming and who don't want to learn from a scratch and who want to get things done in an easier manner. That is why we're finding solutions for you, whether it's from a neuroscience perspective or whether it's from a generic AI perspective, which this is. And again, thank you, Azam, for all your recommendations. Kindly do share this in the group as well, the N8N, and as well as the initial pre-processing tool that you gave us the lecture on. As far as the students go, look, moving forward, obviously we're going to be focusing on the neuroimaging pre-processing, but we're also focusing now on our own model development and the R&D that we're doing that will culminate in us launching this neurocognitive AI model in the hospitals and the diagnostic clinics and helping doctors and helping patients. So anyone who wants to contribute, we can always reach out. We can assign you research stuff because we are really moving forward with this. And yeah, that's about it. I think it's been a very good session today. Azam, I think the students can go and experiment on their own with this N89, and then we can pick it
Yeah,
up
yeah.
in the
I
next
also
session.
share the screen, the documentation screen, and the first tutorial is also available for such link. I also share such link. You see that I open the tutorial links, and you see that you just log in that, and after that you follow such instructions. Such instructions are also available in that. All the steps and triggers are available. And in next lecture, I practically also show you and build some chat model. But this is so much easy if you done such a tutorial. All the things are available in that. Okay, one idea is that which is discussing in last week, me and Sir Ahmed. We make a groups of such people who are really interested in from some research, and research are also the implementation of such research and the publication of the paper. But the idea is that we make a group of three people, at least three people, and the one people have too much the tech idea and tech knowledge. Tech means he has a knowledge of the operating system, and he has also a knowledge of utilization of library like Python, PyTorch, TensorFlow, such like that. Not any in a professional level, but he has an idea how to start and how to do such things. And the other two people are also are their working part. If all the people have the tech idea, it's too much good. But at least one people in such group has a technology idea. And
Yes, Adam, I agree. I think I'm going to put this in the group as well. I'm going to formally write out a statement and put it in the WhatsApp group. So we are looking to make groups of at least three people, like Azam said, because I think individually it is becoming a bit difficult maybe for people to go and explore the especially the neuroimaging pre-processing stuff. So we'll make groups of three people, and then one of them, ideally, one of those individuals ideally should have a tech background or should have an interest in tech. And then the others can have an interest in pre-processing and neuroimaging, or all of them can have an interest in neuroimaging, so that they can then collectively work on a task that is given out. Because right now, the task that Adam gave out about a week ago, I've only had one person who has attempted it. But I have, to be honest, I have got messages from two other people who said they had exams going on and they will try to attempt it after that. So that's why we are trying to reduce the workload for people so that they can find it easier and they can work on it as a group. As far as publications go, Azam, Ahmed Alaisa has been very interested in publications. He actually, when I met him in Riyadh, he told me about his interest last month, and then I will connect him to you because I know you mentioned to me yesterday that you want to document all this R&D that you are doing. And Ahmed also told me that it is very important that we pursue publication for these so that we are able to convince doctors about eventually about the solution that we are building. So I think that is something that we can work on together, me, Ahmed, and Azam. So that is also that something that we have to consider. Zayan, you have a question. Please go ahead.
It's not a question. It's kind of something else. You mentioned you were talking about this website NAN documents, right? I'm not sure about the name. I think
Yes.
I've seen like a similar website to it. It's called Replit, where you also type what kind of AI agent, what kind of app or website you'd like to build, and then it builds it with you. Kind of like similar to this one.
okay, Zian, the difference is that N8N is just like a workflow. In the workflow, you also embed your real applications. Uh, Most of the sites are also available who are building you for agent. That's like if you are using a Copilot. Recently, a Copilot launched by OpenAI Codex, and also a Copilot is also available at Cursor. Such co-pilots and such things also build you all the things, and it's also facilitating you during the coding like ID. But the thing is different from other is that the workflow is too much good, and if you read the documentation, you understand that how the potential for such workflow to other workflow, because such workflow is built for only for such people who has nothing some idea about the programming. All the things are doing in drag and drops and selecting some options, and the you also basically the idea is that you build a strong backend from such workflow, and after the backend is strong, you apply some other JavaScript wrapper on the GUI side. GUI also built such that the site is lovable. Lovable is a site which also provide you a brilliant GUI. Such sites are a recommended site. All nowadays, too much
I'm
other sites are also available.
I'm just going to
Yeah.
add something here. I know of Replit. Replit makes it very easy. I mean, you can go and type, okay, this is what I need, and then it starts making it for you. But this is, and it and is a bit more technical. But you guys have to understand that we don't want to oversimplify things for everyone. That, okay, you know what, we give you something that where you can just go and type and then it gives you everything. We want you to learn what the process is. So I know even Dr. Schwag says this for the pre-processing stuff that, uh, she says that, you know what, we want the students to use the NCAI pipeline so that it's a one-click solution and then they upload the file, it automatically gets converted from DICOM to NIFTI and all the pre-processing is automatically done. It's easy for us to do that, and we've already put the machines in there. As soon as the machines are functional, students can start using that pipeline. But they're not going to learn that way. So if Azam is teaching you like technical stuff, like how to build the folders and where all the files will go and what the input is and what the output is, as an example, it's important for you guys so that you guys learn what is happening at the back end. Because these simple single six click solutions, even I can do it. I don't have a neuroscience background, and even I can use that. But excuse me, but you're not going to learn that way. So same to answer your question, Zian, is the comparison between N8N and Replit. Replit makes life very easy for you. You can just go and type what sort of a model you want to build. But this site that Azam is giving you, it's going to show you at the back end what the workflow is. And understanding the workflow is very important. Even if you don't know programming, it's okay. But understanding the architecture or the framework of the solution is very, very important. And I see you had another question about the 14-day trial period. Yes, it'll probably expire after 14 days. And then what you can do is you can use a different email address and then register for it again. But I think it'll give you enough time to practice over there. Now, Azam, thank you very much for the session today. You've covered a lot of topics, and I think it's been one of our best sessions today. I will urge everyone to go and as soon as the recording is up on YouTube to go and take a look at it. And next week we'll come up with another session. And there are a lot of students who are having exams at the moment, assignments and exams. So that's why the turnout is a bit low today. But inshallah, soon we will have more people coming in. And thank you again. Please enjoy the rest of your weekend and see you guys soon.
Okay, Allah Hafiz.
Bye bye.
Thank you so much, Ahmed and Azam. Azam, I
Mm.
would like to book I want to one session with you. If there is
Mm.
any possibility today, please let me know.
Not today. It's already the 8:15 at Pakistan time. Um, you send me your request. I share you my WhatsApp number. Hopefully, Sunday I take some time from you regarding the session.
Okay. Okay, sure. Thank you. So your
Perfect. Thank
time
you.
zone is Pakistan, right?
I think so.
Yes.
In
Yes,
Sunday.
Azam's time zone is Pakistan, so Pakistan is basically 2 hours ahead of Saudi Arabia.
And what about you, Ahmed? I wanted to make sure because I usually feel shy when I text you.
No, no, you can text me 24/7. I'm always on the go. I'm currently in Pakistan right now. I was in Riyadh actually last week, till last week, for the Global Health Exhibition. So I was there for a good 10 days. So I usually come to Riyadh on the last week of the month. So that's what my usual schedule is. But you
So
can
you
text me
come,
anytime. Well,
you come monthly to Riyadh?
I come monthly. In the winter months, I come monthly. In the summer months, a lot of people are on holidays and it's much slower, so I come maybe once every 2 months. But now in the winters, with the events happening and this and that, we're just waiting for the date finalization from King Faisal Hospital because we're supposed to sign a research collaboration agreement with them. So
Okay.
as soon as they finalize the date for that signing ceremony, then I will come. So ideally, I would like to come last week of November, but let's see. Maybe it might get pushed to December.
Okay. Sure. Thank you. Thank you so much.
Perfect. You're welcome.
Nice.
You're
Thank
Bye
you.
welcome.
bye.
So you can just message Azam privately, and then he can set up a call with you. Azam, thank you again. So I will see you soon.
Okay. Okay. Allah.
Okay. Okay. Allah Hafiz. Bye bye.